So this video we're going to make a summary on the ways to monitor the rate of reaction. So this is the summary table. You can see that the first one, about the gas product. We're going to measure the volume of the gas produced. In this case, we are having hydrogen. So hydrogen, you see that when the hydrogen produced in the process, it will be collected by a gas syringe. So when I have gas syringe right there, connect to a conical flask, and then we can have magnesium here and exit like this. So in the process, if we produce hydrogen, the plunger will be pushed back, and at the same time we also measure the time as well. So the change in volume of hydrogen produced will be measured by the instruments called gas syringe. So this one is an ongoing process. That means we don't need to stop the reactions. It will keep on going. Just remember that SO2 is not suggest to use this setup to do or to measure the rate of the reactions, because SO2 is very soluble in water. So the SO2 produced, it will be quickly dissolved back into the liquid, and then the volume changes will be too tiny to be observed. So the second one, it will be the gas pressures. Again, it's going to produce gaseous product, and it is a closed container, then the pressures inside the system will be increased. So therefore this one is used to measure change in pressure, and we're using pressure sensor and also a data logger. Remember the data logger advantage, we can collect data in a very short intervals for more accurate measurements. And in the process, the change in pressure is not really necessary to produce a gas. Remember, both sides, of the equations, the number of mole of gas product have to be different. Say, for example, if we have this one, then we will see that the one on the left hand side is 3, the one on the right hand side is 2. There's changes in the number of mole of gases produced. So in the process, we can also use gas pressure to do to monitor the rate of reaction. But if we have a reaction like this, then you'll find that on the left hand side we got 2, right hand side we got 2. Then in this case the gas pressures will be the same throughout the whole reactions. So in this case we cannot use a pressure sensor to monitor the rate of reaction. The third one is about the mass. So in the process we see that SO2 is leaving. So in order for the SO2 to leave, we may need to use a cotton wool plug. So for this one, the gas can escape, at the same time prevent the exit from splashing out. So we are using an electronic balance to measure. So this one, we're going to measure the change in mass rate of reactions, and we're using electronic balance. Again, this is an ongoing reactions. But remember, this setup, it is not to measure the hydrogen produced, because hydrogen have a very low density. So even the hydrogen leaves, maybe the electronic balance is not sensitive enough to detect the drops in the mass of the reaction mixture. Next, that would be color intensity. So color intensity, very important, is in the reactions, we should have only one single colored products, colored chemicals. So in this case we have permanganate, which is purple. These are colorless or very pale colors. So this one very pale pink, colorless. So in the process, actually the purple color will become paler and paler as the concentration of the reactant drops. The color intensity of the solutions will also drop. So less light will be absorbed, therefore the absorbance will going down. So this one is about color intensity. So I'll measure the color intensity with colorimeter. So just now I've mentioned about the absorbance, how absorbance change with the color. Remember, absorbance, it will be affected by the concentration of ions, and then it will affect the color and will affect the light absorbed by the solution finally, okay, it would be affecting the absorbance. Okay, remember absorbance is a percentage, so therefore range from 0 to 1. Okay, and it is a unitness. Last one, okay, is about concentration. We're going to monitor the concentrations, okay, of one of the reactant. But this one, remember, is a chemical change. For the one above, okay, all of them are physical change. Okay? All these are physical change. Okay. Why this one is called chemical change? Because you see that, okay, we're going to focus on one of the chemical. In this case, okay, we have NaOH as a reactant, and as time goes by, concentration of NaOH have to be dropped throughout the reaction. So when this one drops, okay, we have less and less NaOH. In the process, okay, we can withdraw some of the chemical in the reaction mixture. So normally the titrimetric analysis, we have 3 steps. We have to withdraw, we have to quench, and then we have to titrate. So when it titrates, in this case NaOH, we will then use acid to titrate with it. So this one is a chemical reactions in the process. For quenching, okay, we mainly cool the reaction mixture with cold water, or we directly pour some cold water into the reaction mixture to like dilute the whole process. Okay, so basically, okay, if we see that there is one acid or alkyl molecules in the reactions, okay, then we can measure the change in concentration of NaOH in this case by titrimetric analysis. But the bad things, the disadvantage of it is we're going to quench the reactions. When we quench the reaction, actually with this actually in the process we didn't quench the main reactions, we just withdraw part of it and then we quench it. But when we withdraw the chemicals out from the reaction mixture, actually we're disturbing the reactions itself. And at the same time, so every 2 minutes we try to withdraw the chemical out. Actually the withdrawal process, it takes time, so therefore we cannot continue or having an ongoing monitoring on the reaction rates. Okay, so basically we have five methods, okay, to monitor the rate of reactions. So in exam, what we're going to do, okay, we'll give you a unknown experiments, say for example something like this, you haven't seen it before, and then we'll ask you to suggest ways to measure the rate. Okay, so normally when you measure the rate, normally you include, okay, what you're going to measure, change in what things, and then, okay, with what instrument, and remember, try to say at regular time interval. Okay, so it will be like this. Basically the answers will involve 3 parts. Sometimes, okay, the answers that you see may not have at regular time interval, but I strongly recommend you to do that one. Okay, so these reactions, okay, we are having propane known, okay, together with iodine, okay, in the process will form an organic compound with H plus and I minus. So you can see that actually we have H plus in the process. As time goes by, more and more H plus will be given out, so this concentration will be increased. We can use this one, okay, as a titrimetric analysis to monitor the concentration of H plus in the solutions. Okay, but the question suggests you to have another measurements. Okay, so you can use it to follow the progress of the reactions. So basically you can see that in this case, okay, other than the H plus, we still have this one, I2. We don't have any gas product. You can't see any gas product, right? So therefore volume of gas produced, pressure changes, or like the mass changes will not be possible. Titrimetric analysis is not there, so only things that we go to will be the colored one. Okay, so we can find that I2 is I2 is brown. I minus is colorless. So on the left hand side, we just have brown solution. This one is colorless. This one is colorless. So we'll be brown, go to colorless. So actually we can using colorimeter to do. When you try to explain, remember, explain everything that you see and you consider. You have considered this one is brown, you consider this one is colorless, you consider the rest of them are colorless. So therefore you know that the color of this brown, okay, in the process will change. How does it change? You have to tell that the concentration of I2 will going to decrease, so therefore the color will get paler and paler. So the change in color intensity can be measured by using colorimeter. Okay, so this is basically what you have to mention in your answer. So I2 is brown, only colored species. So you can see that the others are colorless. So in the process, concentration of I2 decrease. After they decrease, solutions get paler. Okay, so therefore we can use colorimeter measure change in color intensity. Remember, this word is very important. So basically it will be like that. So second one, explain why the above measurements techniques is usually better. That means the one that you suggest is better normally. Okay, you just point out trigonometric analysis disadvantage. We've memorized a few of them, so you just reverse, and that will be the advantage of using the one above. So basically, okay, you can measure, you can monitor the progress continuously. Remember, disadvantage of trigonometric analysis, you're going to disturb the reactions, and also in the process, okay, you have to every 2 minutes you take out some samples out from it, so it is a discontinuous one. Okay, so for this one, okay, you say that monitor color change is continuous. You just put the reaction mixture in colorimeter. They will keep on telling you the change in that absorbance. Other than that, okay, we didn't cause any disturbance to the reaction mixture in this case. We mix the reactant and then we put it into the cells and we put it into the colorimeter. That's it. Okay, so we are causing little disturbance. Okay, doesn't like the trigonometric analysis. So part B suggests 3 different methods that can be used to follow the progress of the reaction. So basically, okay, you look for gas, you look for color, you look for acid and alkaline. This is the way that you're gonna do. Okay, so we can see acid here, so we can use trigonometric analysis. We can see gas here. Oh, good. Volume, pressure, and also the mass. Okay, we'll be able to use. Do we have color change? No, we don't have. So basically, okay, you can volume of CO2 by gas syringe at regular time interval, increase in gas pressure at regular time interval using gas pressure sensor. Okay, and then decrease in mass. Okay, at regular time intervals. Okay, by using electronic balance. Okay, so remember, okay, include the instrument as well. So one more examples. Okay, in class practice 36.9, okay, you're going to suggest experimental method as well, and you have to explain your choice very detailedly. Okay, so basically the public exam, it won't be that demanding. Normally just suggest or the reasons why you pick it, okay, or a very simple explanation will do. So right here, A, okay, we got O2. So O2 is a gas, so you may talk about volume of gas, you may talk about pressure, you may talk about mass degrees, okay. And then second one, okay, we can see this is acid, and then for the rest, okay, no gas. So therefore this one, trigonometric analysis would be good, okay, because the acid concentration as time goes by, it will decrease. And part C, okay, we also got gas, many gas here as well. So we have 4 here, we have 3 here, so you can see there will be a change in pressure. So if I talk about this one pressure, then better this one no pressure, because it say that the procedures not each method can only be used once, so therefore they don't want you to overlap. So basically, A, O2 as the only gas product, so you can measure the volume of gas produced at regular time interval with gas syringe. Okay, so the answers only gas products. Okay, and the second one, you explain acid, okay, can be reacted with NaOH, so the whole things can be changed in concentration of the acid by trigonometric analysis. Okay, so what you need to do, okay, you regular time, okay, you're going to extract, that means withdraw, quench, and then titrate. Very detailed. You can see that even indicator they will be stated here. So last one, okay, you have to say that the reaction involves a decrease in the number of mole of gases. Maybe you're not very familiar with these statements, okay, better include in your notes. Okay, so in the process, okay, it will perform in a closed container, so therefore decrease in pressure as the time goes by. Okay, you can measure this one by pressure sensor connected to data logger. Okay, so basically, okay, the questions will be like that. So to summarize these chapters, okay, mainly we will learn that for the reactions, okay, you look for whether they have gas produced. If gas produced, you can use measure the volume of gas with gas syringe. But remember, SO2, okay, will not be used this method, because SO2 is very soluble in water, very soluble in water. So if SO2 like this, okay, the volume changes will be very tiny, so it will not be easy to see. Same as the pressures, okay, SO2 happens again, okay, the change in pressure is not that significant, okay, so therefore we will not using this method. If we have gas produced, okay, mass can also be used, okay, to change in mass, okay, with electronic balance. Remember, all these have the word change in, okay, change in volume, change in pressure. I didn't write that down because I don't want to make the whole thing so messy. Okay, remember H2 cannot be used this one because it has a very low density. Okay, and then if the reactions, okay, you have one chemical which is colored one chemical, then you can measure the change in color intensity using colorimeter. Last one, if one of the chemical in it is acid or alkaline, normally this one, okay, will be more familiar for you. Okay, then we can measure the concentration, change in concentration of the acid or alkaline with tachymetric analysis. Okay, so your main task for this chapter is to suggest a way to monitor the rate of reaction. Okay, so that's all for this video. Time to finish your chapter exercise. Bye bye.